everyone, are you interested in new techniques to monitor changing coastal hazards? Well, keep on listening. Rising sea level means hazardous wave spray that comes over our coastal defences is becoming more common on windy days. Dense plumes of spray are blown across walkways, roads, railway lines and onto properties. To improve hazard response and monitor how the frequency and the duration of these events respond to climate change and rising sea level, we need accessible real-time observations. A COP26 hackathon led by the Met Office brought together experts in digital technologies and environmental research. They developed prototype tools to collect these observations from public webcam footage, which is becoming much more common around our coastlines.
Coastal community science projects such as Dawlish beach cams, which kindly supplied the imagery for this project, are increasingly becoming an important tool with a dual purpose. Firstly, in educating members of the public toward the pressures of a changing climate, and also as a valuable data source to be used in coastal management. One of the many aspects of community science which has recently proven invaluable in the coastal community is fixed point photography or imaging. So the concept relies on the fact that the majority of people now carry smartphones with cameras which are more advanced than the technology used in coastal imaging over the last couple of decades. And with thousands of people visiting our beaches every day, we can begin to capture their attention and interest and start to gather a daily catalogue of imagery taken from that same fixed point in locations which would normally have none or limited data from a coastal management perspective. These images can then be used to identify seasonal movements in beach material, record the impact of high energy storm events and their subsequent recovery, and also identify any damage done to coastal infrastructure. And the beauty is that the potential application of this recently discovered data source is yet to be fully exploited.
Network Rail has a bespoke forecasting service for the Dawlish seawall. When an alert is received by the route control, the control managers manage the train service safely by running trains in both directions on the same track closest to the cliffs, not the seawall. The design of the signalling system along the Dawlish seawall allows this. This is what is known as bidirectional running.
For over 15 years, we have been measuring and monitoring the coast of southwest England, making this data freely available to those living on and managing our coastline. This includes beach levels, wave height and intensity, coastal habitats, and underwater bathymetric surveys. Our monitoring work helps everybody better understand the coastal mechanisms at work, spot trends, and helps predict future events with more confidence. Understanding the past to predict the future is really important to help communities manage the future effects of sea level rise and increased storminess. Being able to model the impact of climate change on our beaches and associated sea defences will enable our coastal communities, coastal protection authorities and other key stakeholders to work together to create adaptation plans. This will ensure that our coastal communities and our coastal management is resilient, whatever the weather brings.
In the COP26 Climate Data Challenge Hackathon, we set out to build an automated system that can use coastal webcams to spot overtopping, waves coming over the sea wall. Dawlish beach cams kindly gave us access to video clips from one of their webcams for us to use, which looks across the Dawlish railway tracks and out to sea. We decided to build an image recognition system using machine learning. We show a neural network thousands of frames from this footage that contain overtopping and thousands that don't, teaching it to differentiate between the two. Curating thousands of images is a big job, so we got help from dozens of Met Office staff who spent their lunch hours labelling images, overtopping or not overtopping, in a citizen science type effort. The footage that you can see here is a short demonstration of the model output. Calm conditions are given a stay alert warning sign, stormy conditions a caution sign, and visible overtopping events a danger sign. The model is largely successful, with an 80% predictive accuracy over unseen footage containing weather conditions similar to that which it has already seen. We now plan to expand the range of input data that we are feeding it with footage from multiple cameras with different views of the coast and varying weather conditions. Our hope is that we can create a model better able to generalize and translate to other sites around the country. Ultimately, being able to tell when and how often overtopping is happening can help us design better sea defences, provide warnings so that rail operators know when to switch tracks, and generally help us cope with the increasingly severe impact of our changing climate.